Good afternoon, everybody. My name is Vishwadeep, and I welcome you all on Unacademy Computer Science channel. This is the second lecture of Sankalp batch, which is like a resolution we have taken for your GATE rank. And in this particular lecture, I am going to talk about instructions and addressing modes. So what are the instructions? Instruction code, opcode, different types of instructions, and then addressing modes, its types, and there are so many different special questions I have brought today in this particular lecture. And one more specific thing I will provide you today, and that is all the previous year GATE question I have brought in the same PDF, so that as soon as my lecture gets over, I will give you the PPT and you will be able to solve all the questions of all the topics which we have discussed today and yesterday, so that your practice will be on the track and your notes will be in the single source. So without any delay, let's start the session. Before we start the session, let me tell you, this is the 9-day plan. Today is the second day. Yesterday basics done. Today we are going to discuss about instruction and addressing mode. Let me introduce myself for those members who don't know about me. My name is Vishwadeep. I am right now the team leader of Unacademy Computer Science team on the Unacademy brands sales team. My GATE ranks, I have written the GATE exam multiple times. 1919, 440, 682 are few of my ranks. Masters from IISc Bangalore, another masters from BITS Pilani, a rich experience in teaching. These are the courses I am taking on Unacademy's platform for you guys. For your GATE preparation, 2 courses are there: computer organization, data structure. For your interview problems, I am giving you some interview problems also, and I am giving you data structure also, which can help you definitely in the cracking the interviews. If you guys are not aware of the free plans on Unacademy's platform, then today only, just now, create your account on Unacademy's platform. Go to unacademy.com, download the Unacademy app, and create your account using your phone number and email address. Once you do that, go to my profile, search my name, follow my profile, and in my profile you will be having special classes. Those special class section you can listen for absolutely free. Yes, these classes you can join live, plus you can join in the recorded mode also. You can listen all my previously taken special classes. But to unlock free content of Unacademy, you will need a code, and code is this VDEEP10. Use the code and unlock all the free content. If you want to have a free test series, we have a free test series also for you. Enroll for it and you will have really quality questions for your practice. Enjoy the test series and enjoy learning for absolutely free. If you are preparing for GATE computer science, for GATE 21, 22 or 23, and if you want more practice, if you want more effective classes, if you want that every of your doubts to be solved, if you want that you should have weekly test, your doubt solving, everything, then you should go for R Plus subscription. This particular Unacademy Plus is the platform where we provide our such kind of materials, such kind of content, such kind of classes which will be most effective for your learning. You will actually learn how to use your knowledge to solve the problems in the GATE, so that you will be actually knowing that how to solve the questions, how to achieve the better rank using less efforts too. Your every doubt will be solved here. Your every class will be taken in such a way that the class will be very, very interactive. Every live class will be available for you unlimited times, so that you can listen them recorded n number of times. So all these are the facilities in Unacademy Plus, and if you want to join Unacademy Plus, you can take the subscription of 1 month, 3 months, 6 months, 12 months, 18 months, 24 months. And if you want to take the subscription, you will use a code VDEEP10 so that you can get discount. But this code is not just the discount code. It's a code to connect your preparation with my team's effort. There is a team of 8 members which will cover entire GATE syllabus, which will help you in entire GATE preparation. So if you want to connect your preparation with my team, use the code VDEEP10 and enjoy your subscription. Whatever the prices written here, these are the prices after the discount. If you want that you should have a customized or personalized preparation, then that customized preparation comes under Iconic subscription. This subscription has all the facility of Unacademy plus extra facility of having personal coach. The personal coach will give you one-on-one guidance, will give you preparation strategy, will give you planning so that you can have your own customized planning based on your characteristics, based on your day-to-day schedule. You will be having your performance tracked by the expert. You will be having study booster sessions so that regular workshop can brush up your concepts even in more detail. You will be having personalized test analysis so that if you get less marks or average marks, then you can improve those marks by test analysis. And then at the end, this extra practice sets and specialized notes also you will be getting. All these Unacademy plus subscription you can take in these months. Unacademy Iconic subscription you can take with 12 months and 24 months subscription only. And again, if you use the code VDEEP10, this is not the discount code only. It will provide definitely discount, plus it will provide you lots of other facilities including my mentorship plus my team's support. You can see there are so many top educators of country providing your classes on Unacademy plus by the top educator of country. ओके फाइन, चलिए स्टार्ट करेंगे आज का सेशन। और सेशन को स्टार्ट करने के पहले आप लोगों का जोश तो जान ले। हाउ इज द जोश? आर यू रेडी माय फ्रेंड? आर यू रेडी? बच्चों जल्दी से बता दो रेडी हो कि नहीं हो। कंसिस्टेंट प्रिपरेशन बहुत जरूरी है। No matter what, you promise to yourself that you are not going to give up until you achieve your intended goal. आपको छोड़ना नहीं है बिल्कुल भी। So, are you ready? Type down in the comment box you are ready and then we will go further. अगर आपने ये सेशन लाइक नहीं किया तो लाइक कर दो यार, और स्टार्ट करते हैं आज का सेशन। ये रहा पहला पर्टिकुलर स्लाइड। ओके चलिए, a group of bits which instructs computer to perform some operation is instruction। देखिए मैं पहले भी आपको बता चुका हूं, आपका सीपीयू सिर्फ बाइनरी समझ सकता है, तो आप जो भी प्रोग्रामिंग लैंग्वेज में लिखते हैं उसको बाइनरी के इंस्ट्रक्शंस में कन्वर्ट कराना पड़ता है। कौन करता है? आपका कंपाइलर या लैंग्वेज कंट्रोल कन्वर्टर करता है। तो लैंग्वेज ट्रांसलेटर जो है आपके लिखे हुए प्रोग्राम को ऐसे इंस्ट्रक्शंस में कन्वर्ट करता है जो बाइनरी में होते हैं। इसीलिए इंस्ट्रक्शन की डेफिनेशन में लिखा है ग्रुप ऑफ बिट्स, मतलब बाइनरी का कॉम्बिनेशन जो कंप्यूटर को बताएगा कि भाई क्या ऑपरेशन तुमको परफॉर्म करना है। तो समझ लीजिए ये कॉम्बिनेशन ऑफ बिट्स होता है इंस्ट्रक्शन। अगर आपने एक इंस्ट्रक्शन को कॉम्बिनेशन ऑफ बिट्स लिया है तो इस कॉम्बिनेशन ऑफ बिट्स में दो टाइप की इंफॉर्मेशन मोस्टली सीपीयू के पास जाती है। एक टाइप की इंफॉर्मेशन होती है ऑपकोड। कुछ नंबर ऑफ बिट्स क्या बताएगी? ऑपरेशन। ये ऑपकोड क्या बताता है? ऑपरेशन। और बची हुई बिट से क्या मिलेगा? ऑपरेंड्स की इंफॉर्मेशन। अब इन ऑपरेंड की इंफॉर्मेशन में क्या हो सकता है? इन ऑपरेंड्स की इंफॉर्मेशन में मिलेगा आपको, इन द ऑपरेंड्स इंफॉर्मेशन यू विल बी गेटिंग मोड, एड्रेस एंड मल्टीपल अदर थिंग्स। अपार्ट फ्रॉम ऑपकोड, व्हाटएवर इज देयर, एवरीथिंग इज ऑपरेंड्स इंफॉर्मेशन। got it? Okay, so if suppose in some kind of CPU we have opcode is equal to some x number of bits. Let's take a very specific example also. Let's say there is a CPU in which opcode can be of 4 bit in an instruction. So 4 bits say how many maximum opcode combinations you can have. Number of maximum opcodes will be 2 power 4. Answer is 16, which means maximum 16 various operation your CPU can perform. 0000 opcode will denote one operation, 0001 another operation, 0010 another operation, and such kind of 16 various operations, right? Okay, so 16 various operations, एक ऑपरेशन का एक टाइप का इंस्ट्रक्शन। वन ऑपरेशन मींस वन टाइप इंस्ट्रक्शन। तो मैक्सिमम हाउ मेनी डिस्टिंक्ट टाइप इंस्ट्रक्शन दिस सीपीयू कैन सपोर्ट? मैक्सिमम टाइप ऑफ इंस्ट्रक्शंस सपोर्टेड बाय योर सीपीयू। कितना हो जाएगा? 16। मैक्सिमम इज 16। व्हाट इज मिनिमम? मिनिमम कितने होंगे? मिनिमम ऑफ एनी टाइप इंस्ट्रक्शन इज ऑलवेज 1, हमेशा एक। आप बोलोगे जीरो, अगर जीरो है तो इंस्ट्रक्शन ही नहीं है, इंस्ट्रक्शन एग्जिस्ट ही नहीं करता है, तो कैसे बोल सकते हैं कि उस टाइप का इंस्ट्रक्शन है? इफ यू वांट एनी टाइप ऑफ इंस्ट्रक्शन सपोर्टेड, देन दैट टाइप इंस्ट्रक्शन एटलीस्ट 1 यू शुड हैव। ओके, क्लियर? गॉट इट? चलिए, ओके फाइन। तो देखिए, मुझे ना बड़ा मजा आता है जब आप लोग इंटरेक्ट करते हैं। सो व्हेन आई आस्क द क्वेश्चन, यू शुड रिस्पॉन्ड थ्रू योर चैट्स, एंड व्हेन आई आस्क यू गॉट इट और नॉट, यस, नो, एनीथिंग, इफ यू हैव इमोजीज ऑफ दिस वन और मे बी दैट, जो आपको ठीक लगे वो करो, बट keep responding so that your learning will be more. When you talk to somebody, you can remind yourself the concept again and again and again in more effective manner. Your revision will be really good in that case. Types of instructions, various types of instructions we can have, different types of instructions I have marked here: 4 address, 3 address instruction, 2 address, 1 address, 0 address instructions based on the operands. So let's talk about one by one these instructions. 4 एड्रेस इंस्ट्रक्शन, देखिए नाम से ही समझ में आ रहा है, 4 एड्रेस इंस्ट्रक्शन मींस एड्रेस 4 होंगे इंस्ट्रक्शन के अंदर। इंस्ट्रक्शन के अंदर क्या होंगे? 4 एड्रेसेस होंगे। नाउ दीज 4 एड्रेसेस विल बी रिक्वायर्ड फॉर व्हाट? इफ 4 एड्रेसेस आर देयर, शुड आई हैव ऑपकोड और नॉट? आप बताओ, ऑपकोड रहेगा कि नहीं रहेगा? लिसन, ऑपकोड इज मैंडेटरी, नेसेसरी, most necessary part of instruction. Without opcode there is no any instruction. Opcode के बिना instruction हो ही नहीं सकता. There will not be any instruction which does not have any opcode. Okay, चलिए, तो maximum 4 addresses means apart from opcode. Opcode तो रहेगा ही रहेगा, बिना opcode के instruction नहीं. So apart from opcode you will be having how many addresses? 4 addresses. Address number 1, address number 2, address number 3, address number 4. Oh, 3 double लिख दिया. So these 4 addresses will be used for what? First 3 addresses are used to denote the operands. Will be used to denote the operands. And the last 4th one will be giving you address of next instruction. Address of next instruction. You remember, address of next instruction to we keep in program counter, right? So if a PC is using 4 address instruction, means that particular computer system is not having program counter. Program counter is not used. ये पीसी प्रोग्राम काउंटर है, प्रियंका चोपड़ा नहीं, ठीक है, याद रखना। ओके फाइन। सो पीसी इज नॉट यूज्ड मतलब प्रोग्राम काउंटर नहीं। अगर प्रोग्राम काउंटर नहीं है तो कैसे भी करके इस इंस्ट्रक्शन को सीपीयू तक ये इंफॉर्मेशन ले जानी पड़ेगी कि देखो भाई, मुझे एग्जीक्यूट करने के बाद अगला इंस्ट्रक्शन कहां से मिलेगा। कहां से मिलेगा? ये एड्रेस इस इंस्ट्रक्शन का पार्ट होगा, पूरा इंस्ट्रक्शन फेच हुआ, instruction execution will be done using opcode and 3 operands, and after execution this address will be taken to fetch the next instruction. Very simple, right? Correct? Understood that? Okay, so this is one of the format used in 4 address type instructions. So first 3 addresses will be used to denote the 3 different operands, and last address will be used to denote the next instruction's address. Why? Just because program counter is not used. Understood? अब इस एड्रेस को यहां रखने के बहुत सारे प्रॉब्लम्स हैं. What are the problems? First of all, size of instruction large, means program size large, means instruction fetch takes more time. Understanding? इंस्ट्रक्शन फेच में ज्यादा टाइम लगेगा. एंड relocation of instruction is difficult. Why? अगर आपने relocate कर दिया, then you will have to change the addresses here. You will have to change all the instructions and their fourth address part. Next instruction का address सारे instruction के लिए बदल जाएगा. In that case, relocation is very difficult. Understood? Yes, no. Yes or no? अरे जल्दी बताओ रे बाबू. ना Bangdu, you know, right? Okay. Next, three address instruction. Three address instruction says in the instruction apart from opcode maximum how many addresses you can specify? 3. Means you will be definitely having an opcode. Yes. Apart from that, you will be having 3 addresses. Address number 1, address number 2 and address number 3. अब तीनों के तीनों address, all 3 addresses will be used for operands. तो next instructions address का क्या किया जाए? What should we do for next instructions address? Here the program counter is used. Program counter is used. Okay, got it? So if program counter is used, we don't have to keep this extra information in the instruction. Hence, all these problems are solved in the 3 address instruction. And maximum how many operand you can specify in an instruction? 3. Understood? So maximum 3 operand information you can specify within single instruction. मतलब maximum लिखा है मतलब what? Can we specify only 2 operands and will that work? Yes. Can we specify only one operand? Only one operand and will that work? Yes. 0? Yes. Means if we have a computer system which implements 3 address instructions, then that computer system can have instructions which will have only 2 addresses apart from opcode, or maybe only 1 address apart from opcode, and maybe only 0 address, no any address apart from opcode. मतलब 0 address instructions, 1 address instructions, 2 address instructions, तीनों के तीनों possible हैं along with 3 address instructions. All are available. Okay, fine. चलिए, क्वेश्चन है सर, could you provide complete slides of COA? Yes, it is available on our Telegram channel Unacademy Gate CS. Okay, चलिए, okay, fine. So next, this is the most popular and mostly used type. Mostly all the modern day computers are using this 3 address instruction format only. Then we have 2 address instructions. 2 address instruction format will be what? Format is this. Apart from opcode, how many addresses you can specify? Only 2. So you will be having opcode and 2 addresses. Address number 1, address number 2. Suppose you have written an instruction in binary like this. In the binary you have instruction like this 101011. This binary opcode says it is addition. Here address number 1 is 10, address number 2 is 11. 10 means, suppose, assume it's register 2 and it says register number 3. Add R2 comma R3. If we are doing, what should we do? R2 plus R3. Now we have added the result. Where should we keep the final result? Destination कहाँ रहेगा इसका? The destination will be one of these two only, either R2 or R3. Let's assume R2. Means if you can provide only 2 operands maximum, not more than that, and if you want both operands as input, then एक operand उनमें से ऐसा होगा which will be used as destination also. So one operand used as source and destination both. Got it? Got it? Got it? That is 2 address instruction. So suppose there is a computer system and that supports 2 address instructions. Can that support 3 address instruction also? No. No. Maximum 2 addresses. More than 2 not possible. Can it support 1 address? Yes. Can it support 0 address? Yes. But it cannot support 3 address instructions. समझ में आई बात? आगे बढ़े, ये लो. One address instructions. One address instructions are what? One address instruction will be like this, that you will be having format. In the format you will be having one opcode, one address. Maximum only one address you can specify. Apart from opcode, only one address mentioned here within an instruction. तो अगर एक ही एड्रेस मेंशन करोगे तो दूसरा कहां से आएगा? कल बताया था मैंने. Yesterday I told you this. I told you this particular thing yesterday. What I told? One address instruction are supported in or used in, you know which architecture? Accumulator based architecture. Yes, Payal. Good. Amazing. Amazing. So, yesterday I told if we have one address type instructions, just because we know that one input is taken from accumulator, implicitly we need to specify only one operand and we can perform any operation. So one address instructions will have opcode and one address, and such kind of instructions are supported in accumulator based architecture. But in accumulator based architecture also, if one particular type instruction we have which does not require any input, then if does not require any input, then in that case can one address instruction support zero address instruction also? Yes. Yes, it can support. Yes, it can support. Good, Rishikesh. Nice, Manisha. So one address instructions can support zero address also, but one address instruction system cannot support two address instruction or three address instructions. That I guess you are now having a clear idea of. Last one, zero address instruction. Zero address instruction will be having only opcode. So a PC which supports only zero address instruction, those PC are based on stack based architectures. Got it? चलिए, बहुत बढ़िया, बहुत बढ़िया, बहुत बढ़िया. देखिए, सिर्फ और सिर्फ only 4 address instruction system are those computer systems where program counter is not used. Remaining all other 0 address, 1 address, 2 address, 3 address, all others will use PC just because there is no any field in the instruction here I have told that is storing next instruction's address. So I told you that here we are not having PC, then only we are keeping the next instruction's address within the instruction. Remaining all will not have. Why? Just because program counter is used here also, here also, here also, और यहां भी program counter use होगा. ठीक है, आगे बढ़ें. Okay, should we go further? All the members who are live, if you are enjoying, सेशन को लाइक कर दो यार. ओके, चलिए आगे बढ़ते हैं. जीरो एड्रेस इंस्ट्रक्शन. ओहो, डबल डबल आ गया ये तो. डन. अब देखिए, ये जो जीरो एड्रेस इंस्ट्रक्शन है स्टैक बेस्ड आर्किटेक्चर है, मींस द ऑपरेंड्स आर टेकन फ्रॉम स्टैक. So of course stack pointer is required. Yes. Remaining other will also have stacks. Why? Just because stack is not only to store the operands. Stack can be used to store multiple things like return addresses, activation record, or something. So we can have stack in other type of instructions also. Okay, fine. चलिए अब एक क्वेश्चन सॉल्व करते हैं. बड़ा सिंपल सा क्वेश्चन है और बड़ा ही आसान है, आपसे आंसर भी आएगा. कंसीडर अ डिजिटल कंप्यूटर which supports 3 address instructions. If size of instruction 38 bits, size of each address 11 bits, minimum maximum how many number of instruction the computer can support. If any instruction question is given, we need to provide, first of all, we need to start with this format. 3 address instructions means apart from opcode 3 addresses. फॉर्मेट बना लो, बनाओ भाई फॉर्मेट, मैं भी बनाता हूं, आप भी बनाएं. एड्रेस नंबर 1, एड्रेस नंबर 2, एड्रेस नंबर 3. नेक्स्ट 38 बिट का इंस्ट्रक्शन डन. ईच एड्रेस इज ऑफ हाउ मेनी बिट्स? 11 बिट्स. इफ 11 बिट हियर, 11 bit here, 11 bit here, how many bits for opcode then? 11 plus 11 plus 11, 33, remaining 5 bits. So if 5 bits opcode, using 5 bits maximum, how many opcodes you can have? Maximum opcodes will be 2 power 5. 32. 32 आ गया. Maximum opcodes are 32. If maximum opcodes are 32 means maximum number of instructions is equal to 32. Can you tell me how many minimum number of instructions supported by this system? Minimum कम से कम एक तो support करेगा. Minimum 1. Minimum 1. Yes, understood. Okay. One more thing, if you haven't heard that particular statement before, when I started my lecture, I told you whatever the topics till today I will cover. So yesterday we have seen what? We have seen yesterday microprogramming, right? Micro operations and all bit. Then we have seen the basics. Then we are going to see today instructions and addressing mode. All these topics, whatever the previous year gate questions have been asked, all those I have brought in the same PDF today. इस PDF के end में आपको मिलेगा सारे questions जो previous year gate के हैं. Why? Just because I want you to revisit all those questions. You want solutions? In the same channel, go to the playlist section, you will get the solution over there. I have entire playlist of gate computer science, COA, all the previous year gate questions. So I have already recorded in the sessions. You just watch those videos so that you can get the answers, but questions are there in this one. Okay, so don't worry about that. As I told, I have taken resolution. एक संकल्प लिया है, उस संकल्प का सिंपल सा मोटिव है वो आपकी सक्सेस. तो उसके लिए मैं आपके लिए हेल्प कर रहा हूं. आप लोग को सिर्फ कॉन्स्टेंटली कंसिस्टेंटली प्रिपरेशन करनी है. क्लास में आना है, प्रैक्टिस करना है, क्लास में आना है, प्रैक्टिस करना है. चलिए आगे बढ़ते हैं. अगला प्रश्न ये रहा आपके स्क्रीन पे. कंप्यूटर, लैपटॉप, आईपैड या आपके पास मोबाइल फोन जो भी है वहां पे. कंसीडर अ डिजिटल कंप्यूटर सिस्टम विच सपोर्ट्स 64 to address instructions. So first of all we will go for the formatting. फॉर्मेट बना लो इंस्ट्रक्शन का. ये बना लिया. अभी क्या दे रखा है? 2 address instructions, opcode, address 1, address 2. अरे पीडीएफ कहां से मिलेगा? पीडीएफ मिलेगा हमारे टेलीग्राम चैनल से. ई रहा टेलीग्राम चैनल का नाम, Unacademy Gate CS. Unacademy Gate CS is the telegram channel which is our official channel. Go to that channel and you will get all those PDFs which we have taken the classes for on this channel. This particular channel will have all the PDF. Okay, okay, okay. चलिए वापस आते हैं प्रश्न पे. कहां गया हमारा प्रश्न? ईरा. So to address instruction, size of each instruction, size of each address is 8 bits. 8 bits here, 8 bits here. Total 64 number of instructions. If 64 number of instructions, can you tell me opcode bits will be how many? To have 64 combination, opcode will be of 6 bits. Simple. So 6 bit opcode, fine. Size of instruction is what? 8 plus 8, 16 plus 6, 22 bits. Answer is 22. Simple. ओके, कल का क्वेश्चन. सर कल के क्वेश्चन जो है वो मैंने आपको होमवर्क के लिए दिया था. आप आंसर शेयर करो, सॉल्यूशन शेयर करो मुझसे, मैं वेरीफाई कर दूंगा. ठीक है, ओके फाइन. आगे बढ़े. आगे ये लो. In previous question, if instructions are stored in the memory in byte aligned fashion, byte aligned fashion means byte by byte by byte. then space required in the memory to store a program text of 200 number of instructions is how much? Byte aligned fashion, yes, then in that particular case we need to store the instructions byte by byte. So 22 bit का instruction है, 22 bit instruction will be stored 8 bits here, 1 byte 8 bits, then 8 bits on the next location, remaining how many bits? 6 bits. So remaining 6 bits will be stored on next location. Total how many byte it has occupied? Answer is 3 bytes 1 instruction. 3 bytes 1 instruction, 200 instruction, how many bytes? Then for 200 instructions, answer is 200 into 3, 600 bytes. So you need to store the next instruction on the next space. These 2 bits are empty. Why? Just because byte aligned fashion says that you cannot keep 2 instructions information on the same location. Okay? चलिए आगे बढ़ें. अगला प्रश्न ई रहा आपके सामने. If we use 3 bits in the instruction word to indicate if an index register is to be used and if necessary then which one is used. अगर आपके पास एक इंस्ट्रक्शन फॉर्मेट है, उस इंस्ट्रक्शन फॉर्मेट में आपको 3 बिट गिवन है. ये 3 बिट्स आपको इसलिए गिवन है ताकि आप पता कर पाओ कि इंडेक्स रजिस्टर यूज करना है कि नहीं करना है, और अगर करना है तो कौन सा वाला करना है. तो बताओ कितने मैक्सिमम इंडेक्स रजिस्टर यू कैन हैव इन द मशीन. सीओए के क्वेश्चन इतने लेंदी क्यों होते हैं? क्योंकि इमेजिनेशन करना आसान नहीं होता है सीओए को. तो वो सारी इंफॉर्मेशन आपको इमेजिन करने के लिए देते हैं ताकि आप इमेजिन कर पाओ और आंसर इजीली कर पाओ. 3 बिट्स, 3 बिट से आप मैक्सिमम कितने कॉम्बिनेशन बना सकते हैं? Maximum combinations will be equal to 8. कौन कौन से कॉम्बिनेशंस हैं? 0 0 0 to 1 1 1. बट द क्वेश्चन इज कि यही 3 बिट में से आपको बताना है कि आपको इंडेक्स रजिस्टर यूज करना है कि नहीं करना है, और अगर करना है तो कौन सा इंडेक्स रजिस्टर यूज करना है. मल्टीपल इंडेक्स रजिस्टर हो सकते हैं, राइट? तो मैक्सिमम कितने इंडेक्स रजिस्टर आप रख सकते हो? तो हमने कहा जितने कॉम्बिनेशन है उनमें से एक कॉम्बिनेशन ये बता दे कि इंडेक्स रजिस्टर यूज ही नहीं करना है, नॉट यूज्ड, और बचे हुए जो कॉम्बिनेशन है 0 0 1 से लेके 1 1 1 ये बता दे हैं कि विच वन टू यूज. तो बताओ कितने ऐसे कॉम्बिनेशन बचे हैं जो आपको इंडेक्स रजिस्टर बता सकते हैं? 7. हाउ मेनी? 7. तो आंसर आएगा इस क्वेश्चन का 7 सच इंडेक्स रजिस्टर्स यू कैन हैव व्हिच यू कैन स्पेसिफाई मैक्सिमम. 7. ठीक है, समझ में आई बात? चलिए क्वेश्चन आया है कि सर इंडेक्स रजिस्टर का एड्रेस नहीं होता है. रोमित, मैं आज एड्रेसिंग मोड पढ़ाऊंगा, स्टे कनेक्टेड. आई विल टेल यू कि इंडेक्स रजिस्टर का एड्रेस भी हो सकता है. ठीक है, चलिए रोमित बात करते हैं इस बारे में कि इंडेक्स रजिस्टर का भी एड्रेस हो सकता है. ये मैं डेफिनेटली बताऊंगा आपको, है ना. चलिए अगला प्रश्न ई रहा आपके सामने. प्रोसेसर हैज 70 डिस्टिंक्ट इंस्ट्रक्शंस एंड 34 जनरल पर्पस रजिस्टर्स. A 32-bit instruction word has an opcode to register operands and immediate operands. The number of bits available for immediate operand field is how much? तो ये रहा इंस्ट्रक्शन. इस इंस्ट्रक्शन की फील्ड बता रखी है. सो मार्क डाउन द फील्ड्स एंड गेट द बिट्स इन ईच फील्ड. ओके, सो ऑफ कोर्स एक तो ऑपकोड रहेगा. देन टू रजिस्टर ऑपरेंड्स, register operand number 1, register operand number 2 and an immediate operand given in the question. Right? Then now how many bits for opcode depends here. 70 instructions. 70 instructions are there, then how many opcode bits are required? 7 bits. Why? Just because using 6 bits you can have only 64 distinct instructions. So 7 bits. 34 registers. For 34 registers, how many bits are required for register numbering? Register numbering will be of 6 bits. Why? 5 bits के साथ only 32 combination. Right? So 6 bits for register number 1, register 2 also 6 bits. Entire instruction is 32 bits. Then how many bits are remaining for immediate operand? 19 gone. Immediate operands are 13 bits. Got it? सिंपल है, बहुत सिंपल है यार, बहुत 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 सिंपल है. आप लोग बस समझते जाएं और बहुत 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 इजी है. ठीक है? ओके फाइन. नेक्स्ट वन, कंसीडर अ मेमोरी सिस्टम विच सपोर्ट्स टू एड्रेस इंस्ट्रक्शंस ओनली. ओके, तो बना लेते हैं फॉर्मेट, टू एड्रेस इंस्ट्रक्शंस ओनली. ऑपकोड एंड टू एड्रेसेस. Address 1, address 2. The system has 2 power m kilobyte memory, and if there are x distinct instructions by the system supported by the system, then the size of instruction is how much? If we have memory size this, which we can write as 2 power m into 2 power 10 bytes, or we can write it as 2 power m plus 10 bytes. In that case, can you tell me the address size will be how much? Address size will be m plus 10 bits, and here also other address will be of m plus 10 bits. If x distinct instructions, then the opcode will be log of x bits, right? So entire instruction will be how much? Entire instruction will be log of x plus 2m plus 20 bits. Any option matching? I guess no. D option is correct. Now see, in this particular question, which is another tricky question, a small trick I have given here is this k. ये के को आप भूल ही जाते हो, कोई मतलब ही नहीं सर, हमको के को इग्नोर ही करना, हम देख ही नहीं रहे, ये किलो विलो जो भी है हम तो किलो से मानते ही नहीं. राइट? सो 2 power m kilobytes memory means m plus 10 bits in the address, not only m bits, and which is what? Which is exactly this particular question is having. Suppose you have 64 distinct instructions, how many opcode bits you will use? 6 bits. Suppose you have 32 bit or 32 distinct instructions, how many opcode bits? 5. So if you have x number of instructions, how do you get opcode bits from x number of distinct instruction? Log of x base 2, which is what I have written here for the opcode. Simple. log of x का आएगा seal value. Got it? अरे समझा के नहीं रे बाबा? Okay, another question, and this particular question is very very interesting, just because now we are having two different type of instructions supported. I have clearly mentioned in the classroom this type of questions, how you will have to solve on the YouTube, on Unacademy Plus, on special classes, everywhere I have taught. I have given the every single bit of detail. Today I am just going to revisit the topic, that how you are going to solve the questions. So if two different type of instructions supported, first of all draw the format of each type. Two address and one address type instruction supported. Okay, I have drawn the format. Two address type instructions will have opcode and two addresses. Here only one address apart from opcode. Now look at this, 6-bit instructions and 2-bit addresses. So instruction is of 6 bits, entirely 6 bits. Address size 2 bits. Here instruction 6 bits. Address size 2 bits. So here opcode will be 4 bits. Here opcode will be 2 bits. Now I told you clearly you need to start solving the question through or with that instruction which has minimum opcode bits, which has minimum opcode bits. Minimum opcode bits are this 2 address instruction. So we will start with this. With using 2 opcode bits, can you tell me how many maximum opcode you can have? 2 power 2, answer is 4. Among those given in the question, there are 3 2 address instructions. 3 2 address instruction means 3 opcodes are used for 2 address instructions. So how many used opcodes? 3. How many unused opcodes then? 1. These unused opcodes we will use to get the next level instruction. This next level will be divided into 2 parts. ये 4 बिट को आपको 2 पार्ट में डिवाइड करना है. क्या है 2 पार्ट? Previous level opcode bits 2. Remaining 4 minus 2, 2. From these 2 bits, how many unused combinations we are getting from previous level? 1. Into all the combination of 2 bits. Binary, all the combination of 2 bits is 2 power 2, which is 4. That is the maximum 1 address instructions possible. Maximum 1 address instruction possible. Right? So maximum 1 address instructions are 4. Minimum, how many 1 address instructions you can have? बताओ 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 बताओ. बोलो रे बोलो, कुछ तो बोलो. मिनिमम का आंसर तो बोलो. जैसे 1. मिनिमम इज 1. वाई? जस्ट बिकॉज आई टोल्ड यू कि कम से कम एक उस टाइप का इंस्ट्रक्शन तो होना ही होना चाहिए, नहीं तो वो टाइप सपोर्ट ही नहीं करेगा. अदरवाइज दैट टाइप इंस्ट्रक्शन विल नॉट बी सपोर्टेड एट ऑल. सो इफ यू वांट दैट one address instructions are supported, then at least one of that type instruction should be there. So among maximum 4 आप एक यूज कर लो, बचे हुए 3 छोड़ दो. Next question. Consider a system which supports 2 address instruction and 1 address instruction. Fine. The system has 6-bit instruction, 2-bit addresses. Same to same previous question. If there are 3 2 address instruction, 2 address instructions are fixed, 3. Same to same this. Then the range of number of 1 address instruction is कि 1 address instruction कितने हो सकते हैं? Already we have calculated. We have calculated this already. How many minimum? 1. How many maximum? 4. So you can have number of instructions from 1 to 4. You can have 1 address instructions 1, yes, 2, yes, 3, yes, 4, yes. MSQ बन सकता है यहां से MSQ बन सकता है कि among these what are the possible 1 address instructions. So possible 1 address instruction, number of instructions, 1 address type can be 1, 2, 3, 4. 4 से ज्यादा ना. Why? Just because we have 3 2 address instructions and based on that we have calculated that maximum only 4 1 address instructions possible. बोलो हाँ कि ना, समझा कि नहीं समझा? बोलो रे बाबा बोलो. चलिए. In the same, another variation is what? Consider a system which supports 2 address instructions and 1 address instructions both. The system has 6-bit instruction, 2-bit addresses, same to same as previous question. The range of number of 2 address instructions and 1 address instructions is how much? Now number of 2 address instruction not given, but they are asking minimum how many 2 address instructions you can have and maximum how many 2 address instructions you can have. Let's solve this question. So first of all, draw the format. फॉर्मेट ड्रॉ किया. 2 एड्रेस टाइप इंस्ट्रक्शन, and one address type instruction. Two address type instruction will have opcode and two addresses, address 1, address 2. One address type instruction will have only one address apart from opcode. अभी देखिए 6-bit instruction, 2-bit addresses. So 2-bit for opcode. 6-bit instruction, 2-bit address, here 4-bit opcode. Again, we will start with that type instruction only which is having minimum opcodes. Minimum opcodes 2 bits. How many maximum combination of opcode you can have using 2 bits? 2 power 2, 4. So among 4, maximum how many you can use? Maximum you can use 3. क्यों? अगर आपने चारों यूज कर लिए तो अनयूज्ड क्या बचेंगे? 0. और अगर अनयूज्ड 0 बचे तो 0 into something, one address type instruction नहीं रहेगा. There will not be any one address type instruction. Understanding that? So what am I saying is the 2 address instructions can be 1, yes. 2, yes. 3, yes. More than 3, no. So the maximum opcodes are 4, but you can use 2 address instructions. Maximum is equal to 3. 3 से ज्यादा यूज नहीं कर सकते. 3 से ज्यादा यूज नहीं कर सकते. So in this particular question, if they are asking for the range of 2 address instructions, can you tell me range of 2 address instructions is how much? Okay, Lavjeet has given even the answer also. That's great. So range of 2 address instruction will be 1, 2, 3. Minimum 1, maximum 3. Good, Pratik. Nice. Saurav, nice, amazing, super. Now let's talk about one address instructions. One address instruction we have already taken. We have already understood that minimum to आएगा 1. Maximum how many one address instruction possible when 2 address instructions are not given. अगर हमें यहां पे मैक्सिमम पता करना है, look at this. How can this value be maximum? 2 power 2 will be as it is for every combination. We need to maximize this unused combination. अगर unused ज्यादा रहेंगे तो अगले लेवल के नंबर ऑफ इंस्ट्रक्शन बढ़ जाएंगे. अगर unused ज्यादा चाहिए तो क्या करना पड़ेगा? In 2 address instruction use minimum. In 2 address instruction use minimum. So in 2 address instruction, we used opcode is equal to only 1. How many maximum unused combination we can have from this particular level is 3. Let's divide these 4 bits into 2 parts. Previous level 2 bits, remaining level 2 bits. Using these 2 bits, how many maximum combination we can have is 3 into all the combination of 2 bits, 2 power 2. Answer is 12. So maximum one address instruction we can have in this system is 12 only, not more than that. So range of one address instruction is 1 to 12. That's how you are going to solve this question. See, last 3 years, 2 questions have been asked from this particular type of topic. Yes, 3 years, 2 questions, same topic. 2018 then 2020, and I am expecting that this particular topic will be explored more this year too. So you should have all the possible answers with you instantly if such kind of questions come in the GATE exam. Okay, now if you are not understanding that why we are doing this and what this particular method is, you need to listen my complete lecture for that. Whatever the long term classes I am having COA ka, that particular batch topic, you just see the instruction, and there in the instruction DPP instruction problem solving, I have explained this kind of questions, that how these division and this particular method works and why this particular division I'll have to do. Every detail is given over there. Here I'll not be able to, just because it takes half an hour only to explain this one. Okay, fine. Another question for you now. This you will have to solve. Now you have more than 2 types of instruction supported, 3 different. Consider a system with 32-bit instruction, 12-bit addresses. If there are 254 two address instructions and 8001 address instructions, then maximum how many zero address instructions are formulated? Draw all the format, all possible format of the instruction, whatever the format are there: two address, one address, and zero address. Three address, okay, two address, one address, zero address. Done. Now next, formatting and number of bits, you get it. Opcode, address 1, address 2. Here opcode and address 1. Here only opcode. Right? 32-bit instruction. So instruction length is 32. If instruction length is 32 and 12-bit addresses 12 bits here, only one address 12 bits here, no any address, so entire opcode will be of 32 bits. So here opcode is 32 bits. Here opcode is 32 minus 12, 20 bits. Here opcode is 32 minus 24, 8 bits. We need to start solving the question where we have minimum opcode bits. Start with this 8 minimum. So using 8 number of bits, how many maximum opcodes we can have? 2 power 8, 256. If 2 power 8, 256, then used opcodes are how many? Two address instructions, how many presents? 254. So used opcodes for two address instructions are 254. Unused are how many? 2. These unused we will be using for formulating one address type instruction. One address type instruction opcode I'll have to divide into two parts. Previous level opcode bits 8. So first part will have 8 bits, remaining part will have 12 bits. Now same thing. Using these 8 bits, unused combinations are 2 into 2 power 12. How much? 8192. 8192. These are the maximum one address instructions. Now, if maximum are these many, then used how many? Among those one address instructions are used 8000. 8000 are used. So how many unused opcodes? From here 192. Let's go for the next one. Next field, what we need to do here, divide these 32 bits into two parts. What are the two parts? Previous level opcode bits 20. Previous level pe hai 20, remaining how many? 12 bits. Among these 20 bits, how many unused combinations we are getting from previous level? 192 into all the combination of 12 bits, 2 power 12. These are the maximum zero address instruction. And that is my answer. That is my answer. Got it? Understood that? Okay, fine. चलिए आगे बढ़ते हैं. अगला question. So the same thing which I have given in the terms of values, now the same thing I have given in the terms of variables. Now this particular thing you will have to solve. Let's do it together. Consider a system which supports two address, one address, zero address instruction. The system has I bit instructions, A bit addresses. If there are X2 address instructions, Y1 address instruction, then which of the following is correct for maximum zero address instructions? Formulate it. All the formulation. What are the formats? Two address, then one address, and then I am drawing zero address here. Two address instruction, opcode and two addresses, address number 1, address number 2. Here opcode and only one address, and here only opcode Fine. Now how many bits? Instruction length I. Among those, address length, a bit address. So if address is a here, only a here, nothing is here, I total, here I minus a, here I minus 2a. Which is minimum? I minus a or I minus 2a? I minus 2a is minimum. So let's start with this. I minus 2a, maximum opcode you can have with I minus 2a is 2 power I minus 2a. Among those, how many are used opcodes? How many to address type instruction? X. So unused will be how many? 2 power I minus 2a minus x. Let's formulate this now. This particular opcode I'll have to divide into two parts. What are the two parts? Previous level opcode bits I minus 2a and the remaining a bits. I minus 2a plus a is I minus a. Previous level opcode bits, how many unused combinations we are getting? 2 power I minus 2a. Minus 2a minus x into all the combination of a bits, which is 2 power a. Let's multiply this 2 power a inside. You will be getting 2 power I minus 2a plus a minus x 2 power a. These are the maximum one address instructions. Maximum one address instruction. And how many one address instructions are used? Y. So used opcodes are Y. Then how many unused? Unused will be 2 power I minus a minus x 2 power a minus y. Now these unused we will be using to formulate zero address instructions. Zero address instruction, this I bits I'll have to divide into two parts. Previous level opcode bits, इसके पहले के लेवल पे opcode bits कितनी है? I minus a. So I minus a and remaining a. Using these I minus a bits, how many unused combination we are getting from previous level, which is 2 power I minus a minus x 2 power a minus y into 2 power a. Let's multiply this 2 power a inside. You will be getting 2 power I minus a plus a cancel minus x 2 power 2a minus y 2 power a. 2 power I minus x 2 power 2a minus y 2 power a. Answer is C. So that's how you can solve the question. Now one more thing. If this type of question you want to solve in more quick manner, ask me. I will give you a link of a very special class. In that special class, I explained, that's absolutely free. Yes, Unacademy special classes. So I will give you one particular link where I have solved such kind of questions in the chutki mein, and multiple such kind of questions I have solved over there. And I will tell you how exactly you have or you could solve such kind of questions in just quick flash. So that particular method you can access from that special class, and so many such questions also you can get. बहुत इजीली तुमसे सॉल्व होगा और बहुत जल्दी बहुत अच्छे से सॉल्व भी हो जाएगा. ओके फाइन. चलिए अब बात करते हैं अगले टॉपिक की, विच इज दिस वन, instruction cycle. So what is instruction cycle? To execute an instruction, there is a cycle that is used, and that particular cycle has mostly 6 phases. What are those 6 phases? That 6 phases is this: instruction fetch, then decode, then effective address calculation, operand fetch, execution, write back. Instruction fetch is what? Use the program counter value and get the instruction from memory to IR. That is instruction fetch. Once instruction is fetched, you all know PC value is incremented, right? Incremented by what? By the size of instruction. कल हम इस टाइप के क्वेश्चन कर चुके हैं. Whatever the size of instruction is, PC value will be incremented so that PC can point next instruction's address. And that PC incremented after instruction fetch. Once the fetch is done, CPU will decode the instruction. Decode the instruction means opcode part decoded, and CPU will try to know that exactly what operation this instruction wants to perform. Once CPU will get that, after that CPU will decode the remaining part of instruction, addresses and other things. And based on that, CPU will try to get the effective address. Now, what is effective address? Effective address is nothing but address of the operand or the branch instruction mein target address. What is branch instruction? Branch instruction is that instruction which jumps somewhere. So where to jump? That's the target address. That is the effective address. And then once the effective address is calculated, we will know that where the operand is present, its address is calculated. Using that address, go for the fetch the operand. Fetch the operand so that operation can be performed on those operand values. Then execution is nothing but perform the operation. And once the operation is performed, its result will be generated somewhere in the accumulator. Its result should be written back to the destination. Maybe destination is a register or memory operand or whatever. वहां पे जाके हमें रिजल्ट को राइट बैक करना पड़ेगा. दिस साइकिल कंटिन्यूज फॉर ऑल द इंस्ट्रक्शंस. ठीक है, आगे बढ़े. ये देखिए, अब इस साइकिल में दो अलग अलग टाइप की साइकिल्स होती हैं. एक साइकिल में दो साइकिल. सो इंस्ट्रक्शन फेच इज नोन एज fetch cycle, and remaining cycles are known as, or remaining phases are known as execution cycle. Fetch cycle में instruction fetch होगा और fetch होने के बाद पूरा instruction execute होगा starting from decode to write back. तो कभी कभी क्वेश्चन में बड़े प्रिसाइजली लिखा होगा how much time required for execution cycle. Execution cycle means only from decode to write back. क्वेश्चन में लिखा होगा how much time required for fetch cycle. Only instruction fetch. How much time required for execution of entire instruction? Execution of entire instruction means starting from fetch to decode entire instruction cycle you will have to continue with. तो क्वेश्चन को ठीक से पढ़ें फिर ही आंसर करें, नहीं तो बोलोगे सर इसमें फेच का टाइम तो आपने लिया ही नहीं. फिर हम बोलेंगे सर आपने क्वेश्चन तो ठीक से पढ़ा ही नहीं. आईआईटी बोलेगा आपने ठीक से क्वेश्चन पढ़ा नहीं, तो हम भी आपको आंसर देंगे नहीं, आपको मार्क्स देंगे नहीं, आईआईटी का सीट देंगे नहीं. तो यूज योर माइंड एप्रोप्रिएटली. यू नो एवरी सिंगल थिंग बट यू डोंट कॉन्सेंट्रेट ऑन द क्वेश्चन. आपको इंफॉर्मेशन में इतना मजा आता है, ये तो आता है, अरे ये तो हम कर देंगे. पढ़ा ही नहीं क्वेश्चन आपने क्वेश्चन ही नहीं पढ़ा. देखिए बड़ा अच्छा सा एग्जांपल है, बहुत सारे लोगों ने मुझसे ये सुना भी होगा. आप किसी पहचान वाले की दुकान पे गए, दुकान है कपड़ों की, आप पहचान वाले की दुकान पे गए, अरे ये तो अपने को सस्ते भाव में कपड़े दिखा देगा. जैसे ही आप गए वो आपको बिना पूछे कपड़े दिखाने लगा. सर ये देखो नया जींस, ये देखो नया शर्ट, ये देखो नया सूट, ये देखो. आप चुपचाप खड़े हो, क्यों? अरे हमको ये चाहिए ही नहीं, हमको कुर्ता पजामा चाहिए था, तुम जीन्स दिखा रहे हो, गलत बात, हम नहीं आएंगे अगली बार से तुम्हारी दुकान पे. होता है. एग्जैक्टली सेम थिंग हैपेंस विद ऑल दी स्टूडेंट्स व्हेन वी से कि सर सिली मिस्टेक हो गया. अरे तुम क्वेश्चन तो पढ़ो फिर तो आंसर निकालोगे. इंफॉर्मेशन से आंसर निकाल दिया, आंसर पूछा ही नहीं वो निकाल दिया तुमने, तो कहां से मिलेगा मार्क्स? ओके फाइन. चलिए, effective address. Just now I told address of operand in computation type instruction. Computation type instruction means addition, subtraction, and or something. And branch type instruction के लिए target address. Target address means where to jump. The current instruction is branch. It says jump there. So where to jump, that address is target address. Fine. So that is called as effective address. ब्रांच एंड इंस्ट्रक्शन का एक एग्जाम्पल मैं दे देता हूं. सपोज वन इंस्ट्रक्शन इज प्रेजेंट हियर. दैट इंस्ट्रक्शन इज प्रेजेंट इन द मेमोरी ऑन एड्रेस सपोज 200 एंड इट सेज इट्स अ ब्रांच टाइप इंस्ट्रक्शन. And it says after this instruction execution, the next instruction to be executed, this one. And that next instruction is stored on address 210. So instruction, once this will be executed, after that my system to execute this instruction means we are jumping from here to here. This 210 is target address. जहां जंप करना है वो एड्रेस टारगेट एड्रेस. फाइन. चलिए, एड्रेसिंग मोड इज व्हाट? Addressing mode is that field of instruction which specifies that how and from where the operands are obtained. See, look at this. These addresses are mentioned here. These addresses itself cannot specify that this address is giving you operand from register or memory or with somewhere else or somehow in different way. So how exactly using this address you are going to access the operand, or this address will give you how the operand that will be specified by mode. तो अगर एक एड्रेस फील्ड आपके अलग अलग टाइप से आपको ऑपरेंड दिलवा सकता है, तो किस टाइप से इस इंस्ट्रक्शन को मिलेगा ऑपरेंड यूजिंग दिस एड्रेस, ये कौन बताएगा? मोड बताएगा. मोड बताएगा. So mode bit gives you that idea, specifies that how to use the address so that we can get the operand. There are different types of modes. We are going to discuss one by one. We are not going to discuss each and every mode in so much detail. Basic knowledge is enough. Only knowing that what is the mode, how is it working, and what is its utility. That's it. And only basic some of the modes we are going to discuss which are relevant for your case study. So the very first mode is implied mode. Implied mode, implicit mode kind of. See, opcode gives you what? Operation. But sometimes if opcode can give you both operation also and operands also. If opcode itself has given you both, देन एड्रेस की जरूरत है. डू वी रिक्वायर एड्रेस? नहीं. तो यहां देखो, ऑपकोड डेफिनेशन इटसेल्फ डिफाइंस द ऑपरेंड. अपार्ट फ्रॉम ऑपरेशन, ऑपरेंड आल्सो डिफाइंड बाय ऑपकोड इटसेल्फ. एग्जांपल इज दिस INCA. ऑपरेशन इज इंक्रीमेंट, ऑपरेंड इज एक्यूमुलेटर. एक्यूमुलेटर के लिए अलग एड्रेस की जरूरत नहीं है. CPU इज हैविंग इट्स special purpose register accumulator. CPU internally can access accumulator, so you don't have to mention any explicit address. So if such kind of operation is there in the computer system where explicit addressing is not required, opcode itself can specify the operand, then that is implied mode. अब आप पूछोगे सर ये एड्रेस फील्ड में क्या होगा? एड्रेस फील्ड में कुछ नहीं. इफ यू विल बी हैविंग द फिक्स्ड लेंथ इंस्ट्रक्शन, देन यू विल नॉट हैव दिस एड्रेस पार्ट. नथिंग मींस यू विल बी हैविंग एम्प्टी. इफ यू हैव वेरिएबल लेंथ इंस्ट्रक्शन, देन यू विल हैव ओनली टू फील्ड्स इन द इंस्ट्रक्शन, ऑपकोड एंड मोड. एड्रेस रहेगा ही नहीं. दैट इज implied mode. Immediate mode. Immediate mode says that in this particular address part, whatever the value is specified, that is your data, that is your operand. Operand is mentioned within the instruction itself. So if you want to use any constant value for any instruction, like आपने ऐसा लिखा है a equals to a plus 2, then for this particular 2 we can have, or we can use immediate mode. What we can use? Immediate mode. So 2 can be given as immediate value within the instruction itself. You don't have to access 2 from some register or somewhere else. In the instruction only, operand is available. Within the instruction, operand available, immediate mode. Why this particular mode is used? This particular mode is used for initialize registers with constant value. अगर कोई constant value से आपको रजिस्टर को इनिशियलाइज करना है, आप यूज कर सकते हो ये मोड. ठीक है, चलो आगे बढ़े. अगला टाइप, डायरेक्ट मोड. दिस डायरेक्ट मोड is having another name also, absolute mode. What is the meaning? The operand is taken from memory एंड ऑपरेंड के एड्रेस को बोलते हैं इफेक्टिव एड्रेस. दिस पर्टिकुलर एड्रेस पार्ट ऑफ इंस्ट्रक्शन विल स्पेसिफाई द इफेक्टिव एड्रेस. यूज दैट इफेक्टिव एड्रेस, go to the memory, and you will get the operand. How many number of memory accesses? Memory references. How many times you will have to refer the memory? Only one to get the data. Correct? Understood? Fine. Next, indirect mode. अब directly आपको operand नहीं मिलेगा. You will have this address part. Using this address part, you will go to the memory. There you will not get the operand. You will get another address. This address you will use to access the memory once again. Then you will get the operand indirectly. So address part of instruction, this specifies what? Address of the effective address. Now in this particular case, can you tell me how many number of memory references are required? How many number of memory references required for getting the content? One for effective address, one for operand. 2 memory references are required. And this particular indirect mode is used for what? Used to implement pointers. Used to implement pointers. ओके, चलिए आगे बढ़ते हैं. ये रहा. नेक्स्ट वन इज रजिस्टर मोड. ऑफ कोर्स नाम से ही पता चल रहा है कि मिलेगा ऑपरेंड रजिस्टर से. मिलेगा ऑपरेंड कहां से? रजिस्टर से. सो एड्रेस फील्ड विल स्पेसिफाई अ रजिस्टर एंड इन दैट रजिस्टर यू विल गेट द ऑपरेंड. इज देयर एनी मेमोरी रेफरेंस हियर? Is there any memory reference here for data? No. 0. Is there any register reference here for operand access? Only operand access I am talking about, okay? Only operand access I am talking about. Register reference is there for operand access? Yes, हाँ रे बाबा, हाँ हाँ भाई हाँ. What? Register indirect mode. It says the operand, of course you will get from register but not directly, indirectly. How? Address part will give you a register reference. In the register you will get an effective address, not the operand this time. Use this effective address, go to the memory, and you will get the operand. Now if that is the case, can you tell me here in this particular mode to access the operand, do we require memory reference? Yes. How many? 1. Do we require register reference? Yes. How many? 1. Why we use register indirect mode? To shorten the instruction length. So if we can, cut short the instruction length, or if we can have variable instruction size, then we would like to have it shorter, instruction length smaller. To keep the instruction length smaller, instead of putting the direct address of the memory here, we will put the register reference, which will be of smaller size. Register में मिल जाएगा effective address, you can get the operand from memory. To shorten instruction length, this particular mode is used. ओके, चलिए अब बहुत बार लोगों के अलग अलग डाउट्स आते हैं कि सर ये सीपीयू कैसे पहचानेगा? हाउ सीपीयू विल डिटेक्ट दैट दिस एड्रेस इज डायरेक्ट मोड टाइप एड्रेस एंड दिस एड्रेस आई विल हैव टू यूज इनडायरेक्टली टू गेट द ऑपरेंड और समथिंग. अरे ये मोड किस काम का है? This particular mode will help my computer system. My mode will tell, if suppose mode is implied mode, mode bits will be 0000. If mode is immediate mode, mode bits will be 0001. My CPU will detect mode is 0001 means this instruction is using immediate mode. If mode is 0010, direct mode. If mode is 0011, indirect mode. So my CPU will be able to know ki how I will use this address so that I can get the operand. Will I get the operand using this address directly or indirectly, or using the register directly or using the register indirectly? How? That will be given by or specified by this mode. So this mode actually specify in the bit combination that which type of mode my this instruction is using. तो क्या अलग अलग इंस्ट्रक्शन अलग अलग मोड यूज करेंगे? ऑफ कोर्स करेंगे, ऑफ कोर्स करेंगे. So if you have written a particular piece of code, each and every instruction is very very different. One instruction says इसमें मुझे दोनों ऑपरेंड रजिस्टर से लेना है. Another instruction says one operand from register, another operand from memory. तो operating based on the instruction, my mode can be changed. Another instruction says I will have to use the register indirect mode. Another instruction says I'll have to use pointer, means use indirect mode. तो जो आपका इंस्ट्रक्शन है उसके बेसिस पे एड्रेसिंग मोड विल बी सिलेक्टेड. Got it? So all these addresses will be used how to get the operand that will be given by this mode bits. Next is auto increment decrement mode. This particular, oh ये क्या लिखा है मैंने? This is a variant of register indirect mode. And this particular mode is used to access a table of contents sequentially. So if we want to access some number of operands sequentially, same operation, then you can use auto increment decrement mode. It's a variant of register indirect mode in which this register content is automatically incremented or decremented. How? This is the instruction, same operation, mode is suppose auto increment. So this address will redirect us to a register. This register will point us to operand number 1. On this operand, operation is performed. As soon as operation is performed, this value will be incremented. Incremented means now this value will be pointing to the second operand. Same instruction again executed. Still same operation, yes. Same mode, yes. Same address, yes. This register, in this register now content is pointing to the second operand. Operation is performed on the second operand. And it continues till we will access all the operands. And if we want to access the table of content in the reverse order, then we will go for auto decrement mode. Now, yes, table of content is nothing but sequential content. Maybe it can be an array. If we have auto increment, the auto increment mode is post increment. And auto decrement mode is pre-decrement. That is what you need to remember from here. Okay, so if you want to access elements from first to last, use auto increment. If you want to access the elements from last to first, use the auto decrement. That's it. Simple. To access table of content sequentially, we use this type of mode. Next is index register mode, or known as indexed mode. If we use the array access only one element, this particular mode is used to access only one array element, okay, not all. If you want to access array elements sequentially, then sequentially you can access using auto increment decrement mode. If you want to access any array element randomly, any array element koi ek, then you can use this index mode. So what we do to get the address of the array element? कैसे मिलेगा address? Base plus index के through, right? So that you can get the address of the array element, which is nothing but effective address for us. Address of any element is effective address. How do we get effective address here? How do we get effective address here? Base plus index. So instruction which is using indexed mode address part will give you base, index register will give you index. Add these two values and you will get what? Operand? No, effective address. Use this effective address, go to memory, and you will get the operand. Can you tell me how many memory references are there in this one? One memory reference. One मेमोरी रेफरेंस. अब इस इंडेक्स रजिस्टर मोड के दो इंप्लीमेंटेशन होते हैं, टू इंप्लीमेंटेशंस. somebody asked कि सर इंडेक्स मोड में इंडेक्स रजिस्टर तो स्पेशल पर्पस होता है. there are two types of implementation. one implementation is index register is special purpose register. We have a special purpose register, index register. Second implementation is no special purpose index register. No any special purpose index register. चलिए एक सिंपल सा बहुत अच्छा सा एग्जाम्पल है, मल्टीपल चीजों से कनेक्ट कर सकते हो. सपोज आई डोंट नो अबाउट यू गाइस, बट मेरे स्कूल में ऐसा हुआ करता था कि हमारे टाइम पे ना हम लोग को बोला जाता था कि आप स्कूल की असेंबली में आप एक या दो न्यूज पढ़ के सुनाएंगे या बोल के बताएंगे इंग्लिश में. वो तो हुआ करता था. तो सपोज आप एक काम करो कि आपकी क्लास से एक ही पर्सन है जो हमेशा न्यूज रीडिंग करता है. तो हमेशा जब भी आपकी क्लास का टर्न आया आप क्या बोलोगे? सर ये है, ये वाला बंदा न्यूज रीडिंग करेगा. एक ही पर्सन है, स्पेशली उसी के लिए रखा है न्यूज रीडिंग के लिए. अब अगर ऐसा है तो जब भी बोला गया कि आपकी क्लास से न्यूज रीडिंग का टर्न है तो आप क्या करोगे? कहां भाई हमारा स्पेशल पर्सन, जाओ. अब अगर ऐसा बोला गया कि एक क्लास से रैंडमली टीचर चूज करेंगे कि किस पर्सन को न्यूज रीडिंग के लिए भेजा जाए, हर बार एक ही पर्सन न्यूज रीडिंग के लिए नहीं जाएगा, अलग अलग जाएंगे. तो उस केस में आपको स्पेसिफाई करना पड़ेगा कि आज को न्यूज रीड करेगा. सेम चीज मार खाने के लिए भी है, पिटने के लिए भी है. पिटने के लिए भी होती है ना, कि अगर आपकी क्लास में एक पर्सन है, मस्ती कोई भी करे उसको ही पीटना है टीचर को, तो बिना देखे कहां गया ये, इसको पीट दो, मस्ती कोई नहीं करेगा, चुप हो जाएगी पूरी क्लास. बट अगर आप स्पेसिफिक जाना है कि जो मस्ती करेगा उसी को पीटना है, तो फिर देखना पड़ेगा, सिलेक्ट करना पड़ेगा कि कौन मस्ती कर रहा था. अच्छा ये इसको पीटो, ये तो ये इसको पीटो. ठीक है. तो अगर कोई स्पेशल पर्पस है तो फिर आपको सिलेक्शन की प्रॉब्लम नहीं आती है. बट अगर स्पेशल पर्पस नहीं है तो सिलेक्शन की प्रॉब्लम आएगी. ऐसा ही यहां पे भी होता है. व्हाट इज द प्रॉब्लम? द प्रॉब्लम इज दिस कि if we have a special purpose index register, then we don't have to mention that which register will hold the index value. The index register will be implicitly accessed. So in the instruction we will be having only opcode, mode and address. But some of the computer says that देखिए index register is used only for the indexed mode. How many instructions of your computer system will try to access the array using this mode? Very less. बचे हुए instructions में you don't use the index register. Then why you keep a register which will be used only once in a while? बहुत कम टाइम में अगर कोई चीज यूज होती है तो उसे रखना ही क्यों सिस्टम में? So index register we will not keep as special purpose register. So in that case what happens? In that particular case we will be having an instruction and that instruction says कि हम किसी भी जनरल पर्पस रजिस्टर को इंडेक्स रजिस्टर बना लेंगे थोड़ी देर के लिए. Any general purpose register can be used to keep our index value. तो opcode, mode, and we will be having one particular field for saying that which register is index register for this instruction. Designation. मतलब कि among all the general purpose registers, which register this instruction is using as the index register for a short period, and then address part, of course. So it is possible that we have special purpose register. It is possible that we don't have special purpose register in the CPU as index register. So in that case, we need to have extra field which can specify that which register is used to be used as index register. Okay, fine. चलिए आगे बढ़ते हैं. So next one is PC relative mode. PC relative mode is used for branch type instructions. Branch type instructions के लिए how to get effective address. Effective address is the address of the target instruction जहां करना है jump. So this particular PC relative mode says that in this address part we will be having relative addresses कि कितनी दूर हमें जंप करना है, वो रिलेटिव लोकेशन यहां पे मिल जाएगी. उसको ऐड कीजिए पीसी की वैल्यू में, and you will get the effective address, and that effective address is nothing but address of the target address. On that address you will go to the memory, you will get the target instruction. So how do you get the effective address, which is the target address here? Add two things. One is PC value plus address part of instruction, and this address part of instruction gives you what? Relative address, or sometimes it is known as offset also, कि target कितना दूर है. This PC relative mode is used for the branching, and that too intra segment branching. इसी सेगमेंट में अगर जंप करना है तो आप क्या यूज करेंगे? PC relative. अच्छा, एक चीज का आप आंसर बताओ कि PC holds current instructions address or next instructions address? PC holds current executing instructions address or next instructions address? Next instructions address means when we will be calculating this effective address, this PC value will be the address of this instruction or next in the sequence. This current instruction का address PC में रहेगा या next का रहेगा? Next instruction's address. So remember, if for any branch instruction you are calculating this effective address or target address, then remember that PC you need to use as the address of next in the sequence instruction. Got that? Next, yes, next, yes, correct, superb. ओहो, क्या बात है. इतना एक्टिवली अगर आप लोग लर्निंग करोगे तो मेरा मोटिव जो संकल्प बैच के साथ मैंने लिया है वो फुलफिल हो जाएगा. चलिए, नेक्स्ट वन इज बेस रजिस्टर मोड. दिस बेस रजिस्टर मोड इज ऑल्सो यूज्ड फॉर ब्रांचिंग. Means it will also give you the target address, but this branching is little bit different. It says you need to go for inter segment branching. अगर किसी दूसरे सेगमेंट में जंप करना है तो ये यूज होता है. Only difference from PC relative to base register mode is instead of adding this offset value in PC, we will add the offset value in base register. So there will be a base register. Take the address part. This is nothing but offset or the relative locations. Add this into base register value. You will get what? Effective address. You will get what from here? Effective address. Addition will give you effective address. On that address you will get the target instruction. You will get what? Target instruction. That is the base register mode. फाइन. चलिए, अब क्लासिफिकेशन किया मैंने मोड्स का. अलग अलग टाइप का क्लासिफिकेशन है. नॉन कंप्यूटेबल एंड कंप्यूटेबल. व्हाट इज नॉन कंप्यूटेबल? ऐसे एड्रेसिंग मोड्स जिनकी कैलकुलेशन के लिए या जिनमें इफेक्टिव एड्रेस कैलकुलेशन के लिए कोई कैलकुलेशन नहीं चाहिए, कोई कंप्यूटेशन, एडिशन, सब्ट्रैक्शन, इंक्रीमेंट, डिक्रीमेंट नहीं चाहिए. इंप्लाइड मोड नो कंप्यूटेशन, इमीडिएट मोड नो कंप्यूटेशन, नो कंप्यूटेशन, नो कंप्यूटेशन, नो कंप्यूटेशन, नो कंप्यूटेशन. बहुत सारे स्टूडेंट पूछते हैं सर रजिस्टर इनडायरेक्ट और इनडायरेक्ट मोड में आपको डबल बार एक्सेस करना है किसी चीज को, पर एडिशन सब्ट्रैक्शन किया क्या? नहीं ना. एडिशन सब्ट्रैक्शन इज कंप्यूटेशन. नो कंप्यूटेशन रिक्वायर्ड फॉर effective address calculation. That is what? Non-computable. And computable means calculation required. You only say yes, हाँ sir ऐसा होता है. Auto increment decrement mode, yes, computation is required. Addition subtraction, yes. Increment decrement. Then index mode, yes. PC relative mode, yes. Base address mode, yes. So all these modes will require the computation. Among these all, these two modes are used for branching. Control type mode. Control type mode means these will be used for branching. And remaining all will be giving you what? Data. Remaining all will be used to give you the data address. All these will be used for operand access. Operands. These all will give you the operand के address. ओके तो अगर कोई आपसे पूछता है कि इनमें से कौन सा मोड ऐसा होगा जो आपको डेटा का एड्रेस या लोकेशन लाके देगा, तो पीसी रिलेटिव बेस रजिस्टर मोड को छोड़ के सारे मोड्स आपको डेटा या ऑपरेंड्स के एड्रेस देंगे. पीसी रिलेटिव और बेस रजिस्टर मोड आपको ब्रांच के टारगेट के एड्रेस देंगे. ठीक है, समझ गए बात? समझ गए? कंप्यूटेशन का मतलब एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन, इंक्रीमेंट, सब डिक्रीमेंट, इन सब में कोई ऐसा ऑपरेशन नहीं होता है, इनमें होता है. चलिए अब क्वेश्चन सॉल्व करते हैं. कंसीडर अ पीसी रिलेटिव मोड टाइप ब्रांच इंस्ट्रक्शन which takes branch on address 640. Takes branch on 640 means this is the target address जहां पे जंप लिया. Target address. The instruction has offset value 360. Fine. So this is the offset or the relative location. What is the address of the instruction if each instruction is stored in the memory on two locations? I will make you visualize this question. Okay. I'll make you the visualization also. Look at this. So there is an instruction, branch type instruction. This branch type of instruction is using PC relative mode and it says आपको jump करना है. कहां पे jump करना है? Where to jump? Jump address is 640. 640 is the target address. Fine. Now we know that how do we get the target or effective address in the PC relative mode? Answer is PC का value plus offset value. That is the simple formula. Target is given, yes, 640 is equal to PC value plus offset is given 360. Can you tell me what is the PC value? PC value क्या आएगी? PC value होगी 280. PC value is 280. PC value is 280. Now if PC value is 280, PC value is 280, PC holds this branch instructions address or next instructions address? Next instructions address. तो PC में है अभी ये वाले next instruction का address 280 and that 280 is after incrementing 2. क्यों 2 करके? क्योंकि each instruction is stored in the memory on two locations. So this particular instruction is stored on two location. After that 280, can you tell me this particular instruction's address will be what? 280 minus 278. Yes. So current instructions address is what? Current instructions address will be 280 minus 2. Answer is 278. Everything is simple, everything is given in the question. You need to just map your knowledge to the question कि पीसी जो 280 आया है ये करंट इंस्ट्रक्शन का एड्रेस नहीं है, पीसी होल्ड्स द नेक्स्ट इंस्ट्रक्शन एड्रेस. गॉट इट. चलिए यहां से एक बहुत अच्छी सी सिंपल सी लर्निंग मिलेगी आपको, जिसको बोलते हैं सीख. पीसी का वैल्यू, this particular instruction, branch instruction, before this branch instruction got fetched, पीसी का वैल्यू होना चाहिए 278 करंट इंस्ट्रक्शंस एड्रेस. तभी तो पीसी का वैल्यू यूज करेंगे और इस इंस्ट्रक्शन को फेच करेंगे, तभी तो इस इंस्ट्रक्शन को फेच कर पाओगे. 278 will be the value before instruction fetch. As soon as instruction fetch is done, can you tell me after fetch what will be the PC value? After the instruction fetch, what will be the PC value? 278 plus 2, 280. तभी तो आपने ये 280 यूज करके 280 प्लस 360 टारगेट निकाला है. अब अच्छा ये बताओ कि ब्रांच का मतलब क्या है. ब्रांच का मतलब जंपिंग. क्वेश्चन में मेंशन किया है कि ये इंस्ट्रक्शन जो 278 पे स्टोर्ड है ये जंपेगा. कहां जंपेगा? ऑन एड्रेस 640. मतलब कि यहां जो इंस्ट्रक्शन रखा हुआ है ना वो अब नेक्स्ट एग्जीक्यूट होना चाहिए. क्या ये वाला इंस्ट्रक्शन एग्जीक्यूट होगा क्या जो 280 पे रखा है? नहीं 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 नहीं. अगर ये इंस्ट्रक्शन एग्जीक्यूट नहीं होगा तो हमको हमारे प्रोग्राम काउंटर को चेंज करना पड़ेगा. प्रोग्राम में थोड़ा चेंज होना रहता है ना. क्या चेंज होना रहता? कि जो आपका पीसी वैल्यू है उसको आप चेंज करना पड़ेगा. क्यों चेंज करना पड़ेगा? क्योंकि हम नहीं चाहते ये इंस्ट्रक्शन एग्जीक्यूट हो. हम क्या चाहते हैं? ये वाला इंस्ट्रक्शन एग्जीक्यूट हो जो 640 एड्रेस पे है. तो जो हमारा इस ब्रांच इंस्ट्रक्शन का एग्जीक्यूशन होगा उस एग्जीक्यूशन में हम चेंज कर देंगे. इस एग्जीक्यूशन में हम पीसी की वैल्यू एक्सप्लिसिटली चेंज कर देंगे. क्या चेंज करेंगे? 640 से, ताकि नेक्स्ट जब भी इंस्ट्रक्शन फेच हो तो 640 से हो जाए. बोलो हां कि ना. समझे कि नहीं समझे? समझ में आया कि नहीं आया? देखिए समझना जरूरी है. आपको एग्जाम लिखनी है. ये छोटी छोटी बहुत सारी ऐसी चीजें होती हैं जिनसे एक छोटा सा क्वेश्चन निकल के आएगा. आप बोलोगे सर सब कुछ पढ़ लिया था बस ये क्वेश्चन समझ में नहीं आया. क्यों? क्योंकि एक बारीक सी छोटी सी चीज आपने मिस कर दी. इफ यू गॉट इट, समझ में आना चाहिए. Yes, Prem, of course, Bangdu and Jampega are having different fan base. Yes, okay. चलिए, तो अगर इतना आपको क्लियर है तो याद रखें कि अगर कोई ब्रांच टाइप का इंस्ट्रक्शन है और उसने जंप लिया है, ब्रांच लिया है, जंप करना अगर है तो पीसी का वैल्यू आपको अपडेट करना पड़ेगा टारगेट एड्रेस से एग्जीक्यूशन फेज में. अगर वो जंप नहीं करता तो हमें जरूरत नहीं थी पीसी की वैल्यू चेंज करने की. हम फिर नेक्स्ट इंस्ट्रक्शन 280 पे जो रखा था उसी को ही फेच कर लेते. पर जबकि जंप होगा तो फिर हमें जंप करना पड़ेगा, तो पीसी की वैल्यू चेंज करनी पड़ेगी जंप के केस में. ठीक है, ओके. चलिए आगे बढ़ते हैं. किसी ने पूछा है हेरा फेरी के फैन हो सर आप? मैं हेरा फेरी का तो फैन नहीं हूं, बट हाँ मैं हेरा फेरी का जो बाबू भैया का कैरेक्टर है उसका बड़ा फैन हूं. बड़ा मजेदार कैरेक्टर है जो परेश सर ने निभाया है. बड़ा ही अच्छा कैरेक्टर है एंड द काइंड ऑफ प्रोनाउंसिएशन ही इज हैविंग अमेजिंग. चलिए आगे बढ़ते हैं. एक क्वेश्चन है, बहुत बहुत इंटरेस्टिंग टाइप का क्वेश्चन है. इस क्वेश्चन से आपको काफी कुछ सॉल्व करने को मिलेगा, बहुत कुछ अच्छा समझने को मिलेगा. कंसीडर अ 6-word इंस्ट्रक्शन विच इज ऑफ फॉलोइंग टाइप. इंस्ट्रक्शन में है ऑपकोड, 2 डिफरेंट मोड्स फॉर 2 डिफरेंट एड्रेसेस. सो ये एड्रेस का अलग मोड हो सकता है, इसका अलग मोड, ये दोनों दे रखे हैं यहां पे. द फर्स्ट ऑपरेंड डेस्टिनेशन, ये वाला फर्स्ट ऑपरेंड डेस्टिनेशन है. दिस इज द डेस्टिनेशन. व्हाट इज द मीनिंग ऑफ डेस्टिनेशन? डेस्टिनेशन मीन्स ऑपरेशन परफॉर्म करने के बाद रिजल्ट वहां स्टोर होगा. फाइन. यूजेस रजिस्टर इनडायरेक्ट मोड. अब याद करो कि रजिस्टर इनडायरेक्ट में क्या होता है, ये एड्रेस विल गिव यू द रजिस्टर, रजिस्टर से यू विल गेट मेमोरी ऑपरेंड और मेमोरी एड्रेस, वहां से मिलेगा ऑपरेंड. सो वन रजिस्टर एक्सेस, वन memory access. And second operand uses indirect mode. This is using indirect mode. Indirect means two memory accesses. ठीक है. Each assume each operand is of size 2 words. तो हर एक ऑपरेंड 2 वर्ड का है. एंड ईच एड्रेस इज ऑल्सो ऑफ 2 वर्ड्स. वर्ड एड्रेस भी 2 वर्ड का है, तो ऑपरेंड भी 2 वर्ड का, एड्रेस भी 2 वर्ड का. And the main memory takes 20 nanoseconds for one word access. एक वर्ड को एक्सेस करने के लिए 20 सेकेंड लेता है मेन मेमोरी. ओके, देन मेमोरी एक्सेस टाइम रिक्वायर्ड इन फेच साइकिल ऑफ इंस्ट्रक्शन. फेच साइकिल, ओनली फेच. लुक एट दिस, इंस्ट्रक्शन फेच. हाउ मेनी वर्ड्स ऑफ इंस्ट्रक्शन? 6 words. 6 word fetch will take how much time if one word fetch takes 20 nanoseconds? एक वर्ड के लिए 20, तो 6 वर्ड के लिए कितना लगेगा? 6 वर्ड के लिए लगेगा 6 into 20 nanosecond, 120 nanosecond. I hope this is clear to everybody. This is clear to everybody? चलो, execution cycle of instruction. Remember, execution cycle of instruction means apart from instruction fetch, decode to the write back. Fine. So decode, of course decode में तो कोई ऑपरेंड एक्सेस या मेमोरी एक्सेस नहीं होगा. Yes, but effective address calculation and operand fetch will require the memory access. Yes, and that depends on the mode. So in this one, फर्स्ट ऑपरेंड, अगर मुझे फर्स्ट ऑपरेंड चाहिए, द फर्स्ट ऑपरेंड विल टेक हाउ मेनी साइकिल्स? फर्स्ट ऑपरेंड फेच विल टेक हाउ मेनी साइकिल्स ऑफ मेमोरी? indirect mode, register indirect mode, only one memory access of the operand of 2 words, and one word is 20 nanosecond. So initially for first operand access, 2 word access of 20 nanoseconds. After that, second operand access, second operand using indirect mode, 2 memory accesses, one for address, another for operand. If you don't remember, look at this. वापस जाता हूं मैं, ये देखो indirect mode. एक बार में एड्रेस मिलेगा, दूसरी बार में ऑपरेंड मिलेगा. एड्रेस इज ऑफ 2 words, ऑपरेंड इज ऑफ 2 words. So how many times memory access? 2 words 2 times. 2 words 2 times means you will have 2 access each of 2 words, और एक वर्ड का एक्सेस टाइम 20 नैनोसेकेंड. ये तो ऑपरेंड को वहां से लाने के लिए, प्लस राइट बैक टाइम. डेस्टिनेशन इज व्हाट? ये रहा. You will take value this much and this much time required. After taking the value, perform the operation and write back the result. Write back के लिए you will have to access first operand once again. Register indirect mode, only one memory access of 2 words. Yes, 2 into 20 nanosecond. Answer will be 40 plus 80. कितना होगा बताओ टोटल? बताओ भाई. $160 nanoseconds. Total 160 nanoseconds for execution cycle. ये समझ में आया कि नहीं एग्जीक्यूशन साइकिल का? चलो एक बार और क्लियरली बताता हूं, है ना. एग्जीक्यूशन साइकिल बताता हूं. First of all, first operand access. First operand access of 2 word, 20 nanosecond. Then second operand access. It's indirect mode, 2 times memory access of 2 words each, 20 nanosecond for 1 word. This much time. Then write back. Write back will be in the first operand, which will take 2 into 20 nanoseconds. Got it now? If this much is the time required for execution cycle, then instruction cycle will take how much time? Instruction cycle will take fetch and execution total 120 plus 160, 280 nanoseconds. क्या बोलते हो? आया मजा? तो इस टाइप के एक क्वेश्चन पूछा जा सकता है, ओनली फेच साइकिल और ओनली एग्जीक्यूशन साइकिल और एंटायर इंस्ट्रक्शन साइकिल, सम काइंड ऑफ अ इंटरमीडिएट क्वेश्चन और कंप्लीट टाइप ऑफ क्वेश्चन कैन बी आस्क्ड इन दिस. अब इसी क्वेश्चन का एक और वेरिएंट, सेम डिटेल, सेम 6 वर्ड इंस्ट्रक्शन, फर्स्ट डेस्टिनेशन यूजिंग रजिस्टर इनडायरेक्ट मोड, सेकंड ऑपरेंड यूजिंग इनडायरेक्ट मोड, each operand is of 2 words, each address is of 2 words. Now memory is not word addressable, it's byte addressable. Memory is byte addressable and each byte access takes 10 nanosecond time और word का size है 4 byte का. Now अब क्या करेंगे? 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 कोई बोलता है राइट बैक. अरे यार राइट बैक नहीं करेंगे. दो ऑपरेशन, अगर दो ऑपरेंड पे ऑपरेशन परफॉर्म किया तो रिजल्ट तो स्टोर करना पड़ेगा ना डेस्टिनेशन पे, एंड दे हैव गिवन दैट फर्स्ट ऑपरेंड इज डेस्टिनेशन. अगर फर्स्ट ऑपरेंड डेस्टिनेशन है तो हमें उस ऑपरेंड पे जाके रिजल्ट को राइट बैक करना पड़ेगा और उसका टाइम देखना पड़ेगा. एग्जैक्टली द सेम थिंग आई डिड. लिखा है डेस्टिनेशन इज फर्स्ट ऑपरेंड, इसलिए राइट बैक करना पड़ेगा. अब क्वेश्चन है एक वर्ड 4 बाइट का और ये 6 वर्ड का इंस्ट्रक्शन है. 6 वर्ड इंस्ट्रक्शन मींस हाउ मेनी बाइट्स? 6 वर्ड इंस्ट्रक्शन मींस हाउ मेनी बाइट्स? 6 into 4, 24 byte instruction. If 24 byte instruction we have, then fetch cycle will take how much time? 24 byte instruction and each byte access will take 10 nanosecond to 40 nanosecond. Only for instruction fetch. Next, execution cycle. Execution cycle will take how much time? Only one memory access of 2 words. Only one memory access for 2 words for first operand. So 2 words, 4 bytes each means 8 memory accesses, and 8 memory accesses will take each 10 nanosecond. 8 byte access 10 nanosecond plus second operand uses indirect mode, means 2 word 4 words, each word of 4 bytes, total 16 byte access. 16 byte access, each byte takes 10 nanosecond plus same destination access time, 8 byte access 10 nanosecond. टोटल कितना आया? टोटल बताओ. 320 nanosecond. 320 nanosecond. 160 plus 80 plus 80 राइट बैक का भी टाइम इंक्लूड करना पड़ेगा. नाउ इंस्ट्रक्शन साइकिल. फाइनली इंस्ट्रक्शन साइकिल विल टेक हाउ मच टाइम? इंस्ट्रक्शन साइकिल विल टेक fetch cycle plus execution cycle. 560 nanosecond. Clear है? So such kind of questions now you should be able to solve. As I promised you all that I will give you the questions, PYQ questions of whatever the topic we have completed. So all these questions are here. I have brought all these questions in this PDF itself. Look at this, all these questions are available. Whatever the topic we have covered till today, 2 days, in those 2 days, whatever the questions are there, all the previous year GATE questions I have brought here in this table, in the same PDF. आपको क्या करना है? ये सारे क्वेश्चन एक एक करके सॉल्व करना है, all these questions, and you will get this PDF where? In this particular channel immediately after the class ends. if within 5 minutes of the class ends, I will drop my PDF here. Take it, and after that what you're gonna go is these all solutions, all the question solution I have solved in this particular YouTube channel itself, Unacademy Computer Science. Go to the channel, go to the playlist section. In that playlist section you will be getting one playlist of computer organization pre-YQ. All these chapters you can get easily, and every question you can get easily. It's every single question solution I have solved here on this particular channel, so you can refer the solution from there, so you will not be having any problem कि sir question का answer कहाँ से देखेंगे. If you want to learn the courses in more detail, if you are a GATE 22 or 23 aspirant, you will be having more and more and more content on this particular channel, including the all the classes, subjects, crash courses, small courses, large courses, long length courses, engineering math, discrete math, operating system, every course is available here. Just open the playlist, enjoy the learning. That's why we call it as unlimited learning. If you want to be connected with us, you can connect with us on these Facebook pages. And remember, tomorrow का schedule क्या है? कल schedule again the same thing. If you are not aware, this Sankalp batch is running morning 6:30 a.m. to 8:30 a.m. DBMS course by Ankush sir. He is teaching you DBMS early morning. Start your day from here, half an hour break. Then 9 to 11 a.m. you will be having C language by Mallesham Devsane sir, Deva sir, and he'll be taking C language. Then 11:30 to 1:30 you will be having your PM. You will be having your engineering math. Aditya sir will take this class, and tomorrow 2:30 to 4:30 we will meet again to have the classes on COA. And tomorrow we are going to talk about the most difficult part, which is CPU, data path and control unit. So if you are having problem in understanding control unit, microprogrammed control unit, hardwired control unit, data path के question कैसे solve करना है, all these tomorrow we will be learning. DBMS का PDF नहीं आया है, मैं सर को बोल दूंगा, आपको PDF वो ड्रॉप कर देंगे. बिल्कुल ठीक है. प्लीज स्टार्ट अ कोर्स ऑन माइक्रोप्रोसेसर 8086. So Shaumu, microprocessor is not there in GATE syllabus now for ECE also. That's why we are not teaching it here. You may go to our electronics channel, which is Creatrix channel. There you will be getting more microprocessor oriented courses. मिल जाएगा आपको. क्वेश्चन आया सर, री एंट्रेंसी मीन्स क्या होता है? री एंट्रेंसी जो है वो बहुत पुराना एक कंसेप्ट है कि कोई एक फंक्शन को आप बार बार एग्जीक्यूट कर सकते हो क्या? अगर एक बार एक इंस्ट्रक्शन को एग्जीक्यूट किया तो क्या वापस उस पर आ सकते हो क्या? ये 80s 70s की बात है जब ऐसा नहीं हुआ करता था. अब तो हमें पता है एक प्रोग्राम को आप मल्टीपल टाइम्स यूज कर सकते हो, फंक्शन एग्जीक्यूट करा सकते हो ना. तो फंक्शन एग्जीक्यूट कराने के लिए आपको अब स्टैक चाहिए, तो स्टैक यूज करके फंक्शन एग्जीक्यूट करा सकते हो मल्टीपल टाइम्स. दैट इज री एंट्रेंसी. ठीक है. ओएस खलील सर लेंगे? जी हाँ, ओएस खलील सर लेंगे. हेमेचर टेक्स्ट बुक एक्सरसाइज सॉल्व करना इंपॉर्टेंट है क्या? जय किशन, नहीं अभी छोड़ दो, इतना जरूरी नहीं है. नॉट रिक्वायर्ड. इफ यू वांट टू give us some kind of feedback or some kind of return back, do one thing. When these classes get over, go to these classes once again. इन्हीं लेक्चर्स पे वापस आएं और कमेंट्स करें इन लेक्चर्स पे कि ये लेक्चर का आपको क्या पसंद आया, इसमें क्वेश्चन अच्छे थे, एक्सप्लेनेशन अच्छा था, सर ने कंटेंट अच्छा कवर करवाया, सर ने एक्सप्लेन अच्छा किया है. ये से फीडबैक्स आप जरूर दें. प्लस इन लेक्चर के लिंक्स को आप अपने फ्रेंड्स के साथ शेयर करें. बहुत जरूरी है हमारे लिए ऐसे लोगों तक पहुंचना जिनको क्वालिटी एजुकेशन नहीं मिल पा रही है. हम जरूर 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 बहुत मोटिवेटेड होंगे अगर आप लोग हमारे लिए ऐसा करेंगे. आप लोगों की हेल्प से हम मैक्सिमम लोगों तक पहुंचेंगे, और आपके जैसे कई ऐसे लोग होंगे जो YouTube से फ्री क्लासेस से पढ़ना प्रिफर करते हैं, तो उन्हें क्वालिटी एजुकेशन प्रोवाइड हो पाएगी. ये चीज आप लोगों को हमारे लिए हेल्प करनी है। इसके अलावा आप अपने अपने दूसरे फ्रेंड्स को भी बोल सकते हैं। देखिए जैसे कि इलेक्ट्रिकल ईसीआईएम के लिए क्रिएट्रिक्स चैनल है यूट्यूब का, मैकेनिकल के लिए चैनल है, सिविल के लिए चैनल है, कंप्यूटर साइंस के लिए आपका अपना चैनल है, एसएससी जेई का चैनल है, जीएस टर्मिनल का चैनल है जो कि जीएस जनरल स्टडी पे बेस्ड है। तो आप अपने फ्रेंड्स को, अपने सीनियर्स को, जूनियर्स को, अपने सोशल मीडिया पे सब जगह पे इन सारी चीजों को टैग करो और शेयर कर दो ताकि आपके फ्रेंड्स भी बेनिफिट ले पाए। ओके, थैंक यू सो मच। अगर आपने ये सेशन लाइक नहीं किया है तो प्लीज यार लाइक कर दो, शेयर कर देना, सब्सक्राइब कर लो चैनल को और नोटिफिकेशन टर्न ऑन कर लो ताकि आपको नोटिफिकेशन मिलते रहेंगे जब भी हमारी क्लासेस लगेंगी। हैप्पी लर्निंग, दैट्स माय फेवरेट कोट। वी विल सी यू सून टुमारो। टिल देन हैव ए नाइस रिमेनिंग डे। थैंक यू।